we discussed history of web services, how the web services evolved from the single application, and then we discuss about creating web services. So SOAP and REST both, what are the best practices and how thing works. Now we are diving into the kind of edge of that era, which is the microservices. Why? Because today I am not going to teach you how to write a microservice, right? Nest.js or a Spring Boot or whatever the application, you can take it, framework, you can write microservices. That is not what I am going to teach. What I am going to teach is most of software engineers doing things wrong with the microservices. Because this came on around 2013 and this was super popular with the 2015 and so and so. Now it's almost 1 decade, right? Almost 10 years with microservices. So far it's doing great. But again, microservices architecture. What we learned in architecture? Architecture means you can customize. Since you can customize, a lot of engineers get the microservices they want, implement the way they want without knowing the repercussion. If you know what is the correct way, it is completely okay, you customize and do the way you want, because then you know the right practice, and then you know how we are building it, and then you know potential issues can cause. Right? So around 2013, Martin Fowler produced a book saying this is how the web service should go. Right? So before that, we had something called monolith. Right? Monolith application mean everything inside the single application, monolithic applications. Okay? Let's say if you get management system for company, it has HR module, it has a finance module, it has a project management module, it has everything. So when you want to change one thing, right, it probably produce a WAR file for entire your system, your complete system. So now when you want to change one, what you need to do is you need to rebuild this. Right? You need to rebuild this and redeploy the system. Now what happened? Because let's say you are working on a system, so this is the system. Right? Let's say we put a name called Cosmos. Right? This is a Cosmos, it's a monolith application. Okay? Now we have multiple modules. Right? Assume that 50 engineers working on the solution. Okay? Probably 5 engineers on each, 10 modules. Now what happens is, when they want to do some change and go to production, there can be a situation these modules also changed. These modules also changed. Now when they want to go to production, they need to coordinate with many different teams and align with their timeline. Why? Because now you want to go to production on the 1st September. Now they are saying we started a feature, now that is in the code base, we cannot take it back, we need 2 weeks to go. Now we set to 14th September. Right? So now this team says, okay, we are ready by 10th September. We are safe within the line. So they are saying we need till 20th September. Now release is going to be 20th September. Now this feature tested and ready has to wait for 20 more days to go to production. Right? Creating a release train is super hard. Right? How the releases are made, because there are multiple people. And now let's say everyone sync, and now 20th September we are going production. Let's assume like that. Now we need to deploy this. Let's say, for example, let's say you have a Colombo data center, right? And then you have other data center in probably in let's say UK, and there's other data center in the US. Okay? So we are going to discuss different deployment strategies later on in a separate session. But for now let's say you pick this data center, you are going to deploy Colombo data center. Now people who are coming to Colombo data center need to reroute to somewhere else during the period. Okay. So now they reroute to UK and US. Now you are deploying this data center. Right? You deploy this data center, and now you have to run the test, an integration test, and probably sometime UAT, user also come and do the testing. This process takes hours. There are some systems we are starting to deploy on a Wednesday, we are ending the deployment probably on Friday. So now you deployed this data center, this is stable. Now we have a problem, different data center running at different versions. Okay? Why? Because this data center is now updated version. And now we turn back these users to here, and we deploy this and we deploy this, and then we do the global rollout. Okay? So deploying a monolithic application, there are workarounds we used to use. There are techniques we used to do to simplify this process. I am not saying always we have to follow this, but this is the worst case. Right? So now just imagine it went to production, we realize we need to roll back. We have to go through the same process again. Right? So there are different techniques, canary and blue-green deployment, to mitigate these type of issues, but still the root problem is stays same. Now in around 2013, Martin Fowler theorized, no, this shouldn't be the right way to do it. And why we don't have each of these components, each of these as a separate services itself. Right? They have a separate services, they talk to each other. Now they can live alone without disturbing by others. If he want to go to modification, he is not bothering about it. Why? Because he don't have any modification. He don't have to go to production. Right? So this is the basic 35,000 view for microservices. Now where the problem comes. In his book, and later on publication came on the microservices, research papers and the articles and the white papers, they says, okay, if we want to have a successful microservice project, this is how we should do. Now what happens is, though they are proposing that for a reason. Netflix is one of a single organization contributed to this microservice evolvement the most, especially with the Spring Boot. And then Spotify was there, right? And there are a few other companies contributed and kind of running this microservice journey. Now the problem is they came up with those things with a reason. Why we want to do this? We can ignore it. Probably our solution is not that size. Probably our solution is not that scaling. So it is okay to ignore it. But what we need to do is, we need to understand how we can do it right. Because if we don't understand to do it right, we don't know whether what we are doing is wrong or not. Then we go and blame to microservices. I still remember in 2017, I went to a review for a microservice implementation of a large organization. Okay? And they had 12 microservices. All 12 microservices being deployed on a Tomcat. They have a Tomcat server, they just expose the Java file and they create microservices. Technically, not wrong. Why? Because we can customize. Technically, not wrong. But practically and architecturally wrong, because that is, then you, again you cannot say wrong, you cannot get the most benefit out of the microservice architecture. If the microservice has a certain benefit, you cannot take it. Right? Why? Because we are doing it wrong. Now when you say microservices, right, though we write together, there is a micro part. There are so many debates, arguments, how micro the microservice should be. Because let's say when we say someone is beautiful, there is no measurement for the beautiful, right? When someone, if you get the tall or the weight, we can put, okay, we can measure it. But the beauty, you cannot measure it. For someone who's not beautiful for me, may be beautiful for you. This is a relative measurement. So likewise, when you say micro, what is the definition for the micro? To be a microservice, can I take this entire thing and write as a one service, so then will it become a microservice? Why we don't entire, if you put all the business logic in a single service, can we call it as a microservice? Is it based on the number of classes? Is it based on the number of code lines? Is it based on number of methods? There are so many debates going on. And some people came and say each method should serve as a service. Each function or each class need to deploy as service. And some other people start to say no, then that will be a too granular, there will be too many complications to integrate, so we shouldn't do it. And there were so many other things. And widely accepted concept is DDD, domain driven design. Right? Domain driven design. What it means, microservices should focus on the domain which it serves. This doesn't mean in any manner particular domain only have to have one service. That is not the point. Okay? What it means, your design should focus on the domain. So came up with a few principles. Microservice should live for one purpose and do that well. Right? Purpose. For example, if you get the item service, that should only deal with the items. I understand, to create an order you need item. Doesn't matter. Item service responsibility is manage the item. Create item, delete item, update item, issue items, those type of things. Right? Issue is little bit arguable because why you issuing it, right? So, but rest of the thing, yes. When you get the order item, order service need to handle the orders. That order need items, but still order service has to be separate. All the business logic related to the order. When to put the order, when cannot put the order, what are the restrictions, what are the limitations. All business logic stays inside the order. Right? So that means you are doing one thing and do that well. Okay? The second thing is your service should be independently scalable. Independently scalable. Just check our the exam result systems we have. When the A-level or O-level exam released, it's really hard to get the results. You have to, like, kind of a site is getting busy. Now, why? Because result searching modules and all the modules, if we have everything in the one application, you cannot scale it. But if they had different modules, different services, when the result release, they can put more pods on the result search service based on the traffic. I don't know whether they have it now, right? A few years back they didn't. Even maybe they have, it's not auto scaling, right? So now if you do, that's an independent scalable. Okay? Let's say in our organization, for the seasons, we get more orders. Then it not necessarily to shipment or any other service scaling in that aspect. Right? For a beginning of the month and end of the month, sometimes there's so many operations going on, closing and like manufacturer closing, order changes and everything. Right? Probably placing new orders, changing the order quantities. So then we don't need, like, let's say order quantities change, there's something happened and like bulk order quantity change. So then order service, yeah, need to scale to take that traffic. But not necessarily shipment services or any other manufacturing services and or other any item creation services to scale in that aspect. That is independent scalable. Pick your service, we should be able to, okay, today we can see heavy traffic on the shipment services because there are so many shipment is going on. So we can see heavy traffic on the shipment service. Let's scale the shipment service. We don't do it manually, it will happen automatically. Right? But just because of shipment service scale, you shouldn't worry about the item service. So now you might think, okay, what's wrong doing it? Right? Okay, let's scale the shipment service. What's wrong with the scaling the item service? The problem is when you create more service, it consumes more CPU and more memory. Right? CPU and memory equal money. That's how cloud works. Right? So now for people who are on-prem, it's still same. Cloud is a little bit safe because if you need, you can get more servers, right? But in on-prem, you are restricted with the number of servers you have. You cannot go beyond that, right? So therefore, this is the problem. So therefore, we shouldn't scale entire system together. We should be able to independent scale. Third one is independent deployable. Independent deployable. What it means, when this service wants to go to production, they should be able to go alone. They don't have to worry about other services. Right? For example, in our system, we have like 150 microservices running. But whenever we have a release, probably maximum 5 or 6 services going. Sometimes it's 2 or 3. Right? So if we went with this model, when every release happens, we need to deploy all 150 services. But just because of we honor this independent deployable behavior, so therefore, when out of 150 microservices, you can pick few and send. Right? But in practical, sometimes there may be dependencies. Okay, we'll see how we can manage those dependencies. In theory, yes, service shouldn't have a dependencies, but in practical, when you create it, you cannot get that 100%. But when that happens, we do certain things to mitigate the risk and handle those things. If it is a microservice, it has to have a purpose of living. Right? So we call this as a bounded context. That's other term for this one, because it has to have a purpose. The context should be bounded context and independent scalable and independently deployable. Why microservices were so popular? Because microservices solve so many problems we had on the monolithic deployment. Right? Example, release problem and code management problem. Everything was solved. So let's see how we can come up with the microservice. Let's say you have a solution, right? So this is your solution, and then you have HR module, and then you have finance module, and then you have operation module, and then you have project module. So this is your monolithic application, right? So now the real problem is here, what is defined as a service? When you say microservice, what we define as a service. Now if you get the HR, what are the operation HR might handle? Employees, right? Hiring, right? Onboarding, offboarding, right? So let's say onboarding, offboarding, right? Endorsement, data issuing. So there are so many services HR is doing. What we need to identify is to define as a service, what are the things we can isolate as a function and stay as a function. Function means a functionality. For example, endorsement and employees have a relationship. We endorse employees or ex-employees, but employee management and endorsement is a two different functionalities. There is no tight couple, they are not stay together. They are working together but not staying together. Right? You understand? If you get an employee, create employee record and update employee record and delete employee record is functions tied together. because all are doing on the operation on the employee. Right? Now you say, okay, but endorsement now is issued to employee. But this does not change the employee. It is the other attachment to the employee. So it is a perfect candidate. You can go endorsement as a separate service and employee as a separate service. Now there will be two deployments, two different distinguished services. That means two different code bases. Right? If we change endorsement logic, if we change endorsement procedure, that does not impact on the employee. Got it? So let's do one other example. Right? So we have a solution to run our bookshop. Okay? So to run the bookshop, you need to have inventory. Right? Inventory means, let's say, stock. Right? What we stock? We stock item. We stock item, right? And then we sell those. Okay? So let's get this basic functionality. They have maybe staff management and all other things, right? Probably discount and offers and everything, right? So now inventory is what they do. Inventory means you keep the items in a stock, quantities. So now to have the inventory you need item. So it's a perfect candidate you to keep the quantities with the item. But the problem comes, sometime these items, maybe if I have two branches, one branch in Colombo, other branch in Gaul. Now I have 100 quantity, but I need to keep the quantity in a branch wise. I have a 50 quantity in a Colombo and 100 quantity in a Gaul. That means quantity, it doesn't fully tie together with just the item. It coupled with the warehouse or a branch. You understand? So now branch has a quantity. Right? Branch has a quantity. But define the quantity is not the branch alone doing it. So branch and quantity also not fully tied together. We can make it tie together, but it's a good candidate, they can live without tying. So you can have a separate warehouse services also or branch service to manage the branch. Right? So now you create a branch square feet, what is the like kind of area of the branch, what is the stock level, and whether it's you may have a like kind of a different condition like temperature triggering alarm threshold and so, right? Alarm threshold, and there could be different properties which has nothing to do with the item. So that is a good thing. Branch can stay separately because it has its own properties. Right? Because probably gate pass policy is kind of a thing, maybe different from branch to branch. Right? So now item can stay separately. Why? Item just has a few properties. If you get a book has ISBN and name, author, medium, size of the book and weight of the book probably, all those properties. Those has nothing to do with the stock. Right? So inventory can be a separate service. But when I say separate service, those business logic can isolate and run as a separate service. Understand? So now sales, you need branch, you need inventory, you need item, but sales is a different component. We are selling something is a different component. Selling logic can change separately, right? Selling procedures can change separately. Those can change independently to everything else. So sales can be separate. Now sometimes we give offers and discount, probably seasonal. Now we give this discount to sales, right? So you can plug the discount logic into the sales. But the problem is discount changing periodically. Offer procedure is changing periodically. So if you tie together, every season you need to deploy sales service. Right? Every season you need to deploy sales service. But if you put the offer service separately, then we can keep it independently. Right? When new offer comes, probably we change the logic and we redeploy it. So this is designed a way, every time sales goes, let's see if the applicable offers are there. Right? So this is called functional decomposition. Functional decomposition. Right? We decompose functional, but this has to be do very carefully, because the line of separation is sometimes very thin to figure it out which side this should go. How I usually do is, I question myself, can this live separately? Can this operate separately? Why? Because we have two properties, independent deployable, independent scalable. Do we have a requirement to scale this separately? Or do we have a requirement not to scale this when others scale? Right? Can this business logic live separately? Right? Can this change separately without changing this? If yes, it goes as a new service. Now when you say new service, so we in the code management, for the code management we are using some sort of a code repositories, right? Repositories has two types. One is a monorepo, other one is a polyrepo. Right? Monorepo mean for this system, let's say this is a Cosmos, this is the one we put. Cosmos has a one repository. Inside that you have a multiple directories to these services. Right? That this was we used to do. But this has so many problems, because this is like a very close cousin of the monolithic application. Why? So now let's say this is our system, right? So these two work on item service, these two work on inventory service, right? You two work on what is warehouse service. Now, since this is a one repository, PRs, commits, changes, everything is belong to the repository. Right? Now what happened? So you want to go to production, they have put some commit. Now you cannot go to production. Now we have to do so many shortcuts, creating branches and like cherry picking commits here and there, delete the branches, rename the branches, so many drama to go to production. That is why you need, that's why I always say, not you just can write a microservices doesn't mean you know microservices. You need to understand every bit and pieces, the width of this, because everything is coming for a reason. When you violate that, you cannot get that. So now, if the monolithic application, what is the problem we had? We cannot have a deployment easily. Why? Because there can be other changes. Now, okay, good. We have a good organization, we use latest architectures, we do microservices. We use Spring Boot and we use the Nest.js and we do microservices. Right? So now we are good. We can apply for awards and like everything is good. But we hosted on the monorepo. We still suffering same problem. That being said, there are advantages of monorepo as well. For example, running integration test on this type of polyrepo is a nightmare. Because your code base is not the entire code base with you. You need to run 5 different services on your local to run an integration test. Right? But here, when you run the project, you run all the services. One shot, you go. Advantage. Right? So even today, you can start a project with the monorepo architecture. Technically, no one can say this is wrong. But it depends on your use case. You have a super valid reason to do so. I can't think of any reason, but you may come up with a reason. If you come up with a reason, It's a pretty valid to do. When you have a poly repo, so that means we have inventory repo, and then we have warehouse, we have an item, and we have a sales, we have a discount. So now we have 5 repositories. The good side is, the beauty of this can assign to 5 different teams. Now deployment happen in 5 different pipelines, probably Git workflow or Jenkins or Ansible or whatever, but 5 different workflows. They are like 5 independent countries. They make their own decision, whether we fix this or we don't fix this, when we fix this, when we go live production, can we go to production, right? So they are very independent, they can make their own decisions. In a world map, that this one service means single isolated country, right? Why we say, because when you say this, let's say in the world map, it's different countries, right? So why I say this is the same, equal to this one, to enter to this one country from other country, you need a special permission, right? You need to understand their language. It's the same thing in microservices. That's what I say, microservice deployment service has to be like one independent country. Because if you need to talk from item service to inventory service, right, you should be able to talk in a way that they answer you. And you have to have a separate passport to go there. Just because of they are working together, you cannot just freely go there. They are checking security and everything. We are going to discuss next. Now if you get a domain, right, domain can have multiple services, okay, and service have a single repository, right, R1 and R2. The microservice concept says you hold your data, okay, you own your data. That means each service supposed to have own database. Each service supposed to have own database. Now here's how it goes. So now principle says each service has to have own database. Now we don't ask why. We just say okay, that's the best practice. One service, one database. Now we go and create a microservice cloud with 150 microservices. We end up with 150 databases. Right? So 150 databases mean 150 backups. If something fails, 150 restores. The shipping those backups, right? Because data is the most valuable thing. The more you have the copies, more you expose the data to outside. It creates more problems. So the question is, we should ask why it's suggesting you to have your own database. Here's the problem, right? So now let's say you have one database, one central database, right? All the services are connecting. Sales, item, shipment, order, all services are connecting. Now order service has a very high traffic. Sometimes we see millions of messages are being processed. So now when the order service has a very high traffic, they consume all these connections available on this database. Now this can scale, right? I have a 50 instance running. I get more traffic, 75 instances, more traffic, 100 instances, more traffic, 150 instances. This goes, right? There are systems running like 20,000 instances on the clusters. Right? But to run those thousands of instances, now they all talk to database, single database. Now they get the heavy traffic. When this poor guy try to reach the database, they don't have a connection, right? So you are propagating the failures. So because of you busy, you don't let others to work. So now let's say this service, item service, is just creating few more items. Now items cannot create because there are orders, right? So now when you say okay, we cannot create the items today because there are so many orders going on. What's the relationship? Okay, let the orders to go, you create your item. right? So there is no correlation. So to avoid that, because scaling database is not easy as scaling service. Scaling service is seconds, right? Auto scaling, within seconds it spin out more and more services. You can go from 0 to 100 probably within 15 seconds to 30 seconds. But going database scaling is not that easy. Because when the new database comes, instance comes, it has to aware about the data created by this one. The replication has to happen. It's not easy. There are databases like Cassandra, we can like plug the instance, then it automatically building based on the other instances available, but still there is a time. So what we do is, therefore, we says, okay, you write into your own database, then you don't break others, right? You may die exposing connection, but you don't propagate that break up to the others. So now there is a reason. Okay. Now, what I usually do is, when I have a deal with 150 microservices, I don't create 150 databases. What we can do is, instead of, we can get all the services related to the domain. HR domain services, what we discussed, HR service, onboarding service, employee service, onboarding, offboarding, endorsement. Those are all HR related one, right? And then if you get this one, so sales is a 1. This side is inventory, right? Can be ship, if there is a courier or something to handle, then can be logistics services. So those domain can have a database, right? Domain can have a database. So all the services are stay in the sales database. All the product services are in the product database. All the manufacturing services are talk to manufacturing database. Okay? So that is the, now when you do that, see this one, okay? See this one. Let's say inventory service and item service. Okay? Now, no, let's say inventory service and a sales service in a 2 different domain, right? So inventory service in the inventory database, sales service in the sales database. Now, let's say they are on the same cluster, right? Same cluster, 2 different databases. Like if you get the MySQL or Oracle, you create the server, you can create a multiple databases called schemas, right? Now sales invoice service, right? Invoice service can see the stock table, right? But this is in a different domain. That means a different database. You can make a connection, but you shouldn't do it. You don't get the data in a database level from any other database than your database. It is valid even you have a single database, and we have services which have a dedicated database, right? We have a service, even though we go with its domain, and we have a situation where the domain have a database, but there is a service which is particularly have a heavy demand. It processes like 2 to 3 million messages per day. So then that service talking to these databases can cause problem. So it carrying its own database, right? So just because of our architecture says one database per domain, that doesn't mean you have to stick to it, because those are not the rules written by the code, right? You can customize it. So what we have done, domain has a database, but that heavily active service, it's like a volcano. It's the morning, it's starting like a heavy load, and then the noon it goes, and then the end of the day it's processing, and also midnight, right? Or the correction and everything works. So then it has a high read write, right? For that one, we have actually 2 database for this particular service. Just for read is 1 and write for 1. Internally we syncing. Why we do that? Because there is a heavy demand, right? There's a heavy traffic going on that one. So now theory is this, and the practically you should follow this. No matter it's your domain database, because when your service is tied to a database, probably your own database or your domain database. You should not database level connectivity. You should make database level connectivity any other database than your database to read the data. Okay? That being said, sometimes we have multiple data sources. I am not talking about this. For example, if you take our system, we have multiple data sources. We are talking to ERP, right? So ERP data we are cloning in a database. So then you connect to two different databases. That is fine. But I am saying business logic wise, you shouldn't talk to database. Then how you do it? From item service, so sales service, you talk to inventory service. Inventory service talk to the inventory database and give you the results. You connecting over HTTPO, it's a big O. What is this sign? HTTPO, any other way, right? It can be messaging or something. Yesterday they didn't know what the pipe sign mean. They were looking in everywhere in the keyboard, what is the pipe sign? Luckily one person knew it. Right? Okay. So that's the rule. You are not talking to any third database other than your database. That can be your domain database or your own database. We discussed how the service is created and the repository for service, and we can deploy the service as well. Now the problem is team size. How these service should manage. Right? Again, there are so many debatable things came. So the other way, full stack team came into the picture. Okay, full stack team. Sometimes people have, not the people, organization has an idea. Full stack engineer is like IT department. He know the database, he know the front end, he know the back end, he know the deployment, he know the QA. No, it's not like that. Full stack means you master on something, but you know other areas as well. If you are a back end expertise, you know back end very well, but you can handle front end. If you are a front end expert, you know front end very well, you can handle the back end. Okay? So there was a different team cultures came to this paradigm, but standard convention method was, they were saying 2 pizza fed team is the team size, right? When you say the pizza, again Sri Lankan pizza is very small, right? So you have to take the US pizza size. So 2 pizza fed team mean the team should be able to fed by 2 pizzas. Okay, so it around around 8 to 10 people per particular team. This include lead and the engineers, senior engineers. Sometime I have seen team running to 15, but this is kind of a little overkill. But if the architect and the PM and everyone included in the team, this is fine. Okay, but otherwise if you get the developer wise, so what we do is a pyramid. Okay, so we have the lead, and if the lead has 2 senior engineers, then there will be 3 engineers and there will be 4 associate engineers and so and so. We create a pyramid, resource pyramid. Okay, and again these are kind of things we do, no rules or nothing like that. So some may be creating this pyramid in other way around, right? So there are so many leads and one person to do the work, right? Possible, can do. Okay, and why we do it? So then the team is responsible for do almost everything. Okay, for example, the project they are working on, the project Apollo, so they developed it, now they are testing it, and they wrote the pipeline to deploy it, right? And they designed the database, they did everything, almost everything they did themselves, right? From the beginning they create the services, and then they wrote the deployment pipelines, and they deployed themselves through the Git workflows, and then manage the AWS configuration and everything. Sometimes it stopped working and it's entire cluster, right? So we learning and we working. That team is doing everything. So that's a fully featured full stack team. Front end, back end, deployment, testing, everything, right? But we don't have any separate QA engineer also. We don't have a separate dedicated QA engineer, dedicated deployment person who is doing it. They really full stack, end to end, they are working on that. So that type of the team is really work for the microservices. Okay? Why? Because each domain has a particular team. Sales domain, maybe 5-6 services, they have a team, right? Marketing domain, they have a team. Okay, manufacturing domain, they have a team. Let's say for a sales team, they need some sort of a change happen in the manufacturing service. Then they create a ticket on their team's backlog. Hey, we need this column coming on this response. Okay, and they are going to modify it. It's a truly independent team. They have their deployment. So now they are saying, okay, this will be go live on this particular day. So now you plan your one because independent deployable. They can go first and you can go late. There is no reason. Production. There is no reason like that. Okay, there is no reason like that. So any other question? Because this is need other hour to explain the rest of the things, right? So we will have a other session, Microservice, because then we need to deploy. We need to discuss deployment strategies for microservices, the right practice and the deployment strategies, right security practices, right? So there are so many aspects to go. This deserves like 2 hours or a little more than 2 hours also. And this is kind of a 1/3, 40% of entire thing we need to learn about microservices practices. Right? There are so many other things. How to talk to each other, how we can, there are design patterns, proxy patterns, scatter patterns, circuit breaker patterns, especially involved bulkhead patterns involved in this microservice architecture. Right? So we are going to discuss everything in detail. So we'll do that in the next session. Okay? Because if I start next topic, it needs other like 30 minutes or so, which I don't have that time. Okay?